everyone. How's it going today? I hope you're having a good day. So the first thing I want to mention is that if you didn't, I know yesterday's video was kind of long, but transformations take some time to go through. So if you didn't finish up yesterday's assignment, go ahead and take some time today and work on that. And then you'll have some time tomorrow as well to work on yesterday's assignment because tomorrow, Thursday, is a testing day for all of the high school campus. So everyone on campus is going to be involved in testing somehow, except for the freshmen. But the freshmen will be everywhere else because they're using all the teachers to give the PSAT and the ASVAB. So I won't be assigning any new material tomorrow. So you'll have some time to finish up that transformations activity tomorrow as well. So take some time and work on that. I do want to go ahead, though, today, and we're going to move on, and we're going to start talking about slopes and lines that are parallel and perpendicular. So go ahead and hop on over to the modules page. If you go to the bottom, you'll see this assignment here that says Make It Right. So I'm going to open this up. It's a CAMI assignment because it's an activity that my students in class are actually going to do on paper. But this is what you will do. And what I want you to do is I want you to fill out these parts here with me as we go along. We're not going to be looking at any notes in our journal today. But what I'm going to do is I'm going to hop on over to my cell phone. I'm going to set it up so I can actually write on this piece of paper. Because notice it's telling you to use a protractor and it tells you to use a ruler. You may not have those things at your house. You may not even have a printer where you could print these out, but you can still use, do this on the screen with how I'm going to do it on paper. So I'm going to hop over to my cell phone. And so your assignment for today is, which shouldn't take long, is to go through this and let's see what can we discover together about the slopes of parallel and perpendicular lines. So I'll be right back in a sec. I'm going to hop on over to my other. Okay, so here I am with the actual piece of paper. I know there's kind of a shadow over here. I apologize for that. So what we want to do is, it says use a protractor. If you don't remember, that's the thing that looks like a half moon with the ruler on one side that you can measure angles with. To prove, first of all, or to determine if the two lines, so these two lines here, if they're perpendicular. So let's refresh ourselves. What does perpendicular even mean? If you have two lines that are perpendicular, what's it mean? Well, remember, they form a 90-degree angle at their intersection. So where they meet, so for instance, like this angle here would be 90 degrees. Now, maybe you don't have a protractor at home. If you do, great, get it out and use it. Most people don't. I don't even have one in my house, so don't feel bad if you don't. What you could use is a piece of paper. Because let's think about it. This piece of paper, this is a square. This is a Postit Note. So if you have a Postit Note that's colored, brilliant, use it. If you don't, get a normal piece of paper. Just use the corner of a piece of notebook paper. That'll work just fine too. I'm going to use this because it's bright and I think it's going to help you guys see it a little bit better. But remember, this is a square. So these angles right here on every corner are 90 degrees. So let's use our Postit Note to see if where these lines are meeting right here is 90 degrees. Oh, what do you know? Look at that. It like fits it perfectly. And we could go along and we could prove it with every single corner. Oh, so that's what's special about these. These two lines are meeting. They are perfectly 100% perpendicular because look, everywhere they're meeting, all four corners, all four angles of intersection is perfectly 90 degrees. So are they perpendicular? Well, yes, they are. We just proved it. So I know you're going to be writing this on CAMI with your Chromebook, and that's cool. But you could even take your Post-it note or your corner of your piece of paper, hold it up to the screen. It should still look perpendicular. Well, if that's the case, then let's find the slope of both of these lines because we're really, really interested And what are the slopes of lines that are perpendicular? We want to see, is there a pattern? Is there something that we could observe? We're going to be like, we're scientists here. So I'm going to name this line, I'm going to highlight it. I'm going to call this one line 1. So let's find the slope of line 1. So remember, to do that, you need 2 like really good points. I think I'm going to go with these 2 points right here. Those look like really good points. So I'm going to rise up, that's 2, and then I would run over 1. So my rise over run for this is 2 over 1, which I can just simplify to be 2. Okay, cool. So now I'm going to find the slope of my line 2. That's this line right here. So let me find 2 really good points. I know this one looks like a great point right here. I think I'm going to use this point right here. Let's do that. So I would rise up, and then I got to run. Well, I got to rise up 1, and I'm running 1, 2. Oh, wait a second. I'm seeing something here. So for this one, my rise is 1 over my run, which is 2. But now I'm seeing something else about these lines. This pink line right here, I notice is a positive slope. But my purple one, that's a negative slope. So my 2 slopes are 2 and negative 1 over 2. That's kind of interesting. I'm noticing here that this one I had to rise 2, run 1, but this one I had to rise 1, run 2. So I noticed those are swapped. That's interesting. Let's keep that in mind. And I notice one's positive and one's negative. Okay. Well, let's see if those are observations that we can keep. Let's do it again. Anytime scientists are going to see if their observations are true, you have to repeat your experiment. So here I go with my Post-it note. That looks like it's matching up perfectly. Let me put it in this corner. Matching up perfectly. Yep, matching up perfectly. And again, let's see. Yep. So these lines are also perpendicular. There's no doubt about it. Yes, these lines are also perpendicular. So let's find the slope of line 1. I think I'm going to make this one line 1. It doesn't matter which line you make line 1 and which one you make line 2. You get to pick. Let's see. I've got a point right here I'm going to use. I think I'll use this point right here too. So here we go. Let's rise up. And then I'm going to run to this point. So my rise is 1, 2. So I got to rise 3. I'm only running 1. So that's 3 over 1, which is just equal to 3. However, I am noticing that this line is negative. So I'm going to have to make my slope negative there. So the slope of my pink line is negative 3. Okay, so let's go with line 2 now. So that's going to be this other line right here. So let me find 2 good points. This one's sticking out to me. That's a good point. And I think I'm going to use this one right down here, which happens to be the y-intercept. Okay, so let's rise up. So I rise up, and then I got to run over to my point. Well, I rise up 1, and then I run. Now, last time, my rise and run were swapped. Let's see if that's happening again. I rise up 1, and I run 1. Oh, it is. It happened again. I run 1, 2, 3. So it happened again. And I know this purple line is positive. So remember, slope is rise over run, so it's 1 over 3. This is interesting. So what observation can we make about slopes of perpendicular lines? Now, you can put this in your own words. I'm interested to see what your own words are. So like I'm noticing perpendicular lines. Both times I noticed positive, positive, negative, negative, positive. So one's positive both times, and then one is negative. Okay. It wasn't always line 1 that was positive, or like that kind of swapped around. So I don't really know that there was a pattern there, but I do know that one is positive, and both times one is negative. Slopes. So one is positive slope, put that, and then one is a negative slope. And then I noticed that this is 2, or 2 over 1. This one became 1 over 2. This one was 3 over 1, and line 2 was 1 over 3. So I'm noticing, and that's what we said, our rise and runs were swapped. But that makes sense, right? That's the same thing, because rise is on top and runs on the bottom. So it looks like to me, when it's a fraction, because negative 3 is the same thing as negative 3 over 1, this is just this fraction flipped upside down. Do you notice that? So the rise and the runs swapped, which means the fraction is flipped. So that's how I would put it in my words. I would say, I notice one's got always negative, one's positive, and then the fraction flips for the second. I think I just forgot the O there for the second line. Now you can say that however you want to say that. And we're going to come back, remember, on tomorrow, not tomorrow because it's testing day, but we'll come back on Friday and we're going to summarize this in our actual math terms. But yeah, so the fractions are flipped, and I'm noticing one's positive and one's negative. Okay, well there's another type of line we want to look at too. Parallel lines, okay? So what do we remember about parallel lines? Well, parallel lines never, ever, ever touch, right? They're always the same distance apart. And you should remember that from like 4th grade when y'all learned about parallel lines. So do parallel lines ever touch? Nope. And they're actually always the same distance apart. Because if I have 2 lines, let me use my pens. Okay, so if I have 2 lines and they're not the same distance apart all the time, well, remember, lines keep going. So if these keep going, eventually they're going to bump into each other. So they have to remain the same distance apart between them the whole time. Otherwise, one tilts a little bit, and then because those lines would keep going forever and ever, they're eventually going to bump into each other. So that's the thing about parallel lines. They have to be the same distance apart. So if you have a ruler at home, and my ruler is kind of hard to see my marks on here, but you could measure, oh look, these are exactly 1 inch apart. Let me go down here and see if they're still 1 inch apart. Yes, they are. They're exactly 1 inch apart. All along, 1 inch apart. Oh, okay. So I've already determined, because I've measured these lines. Now this is not super duper scientific mathematical proof, but this is as good as we're going to do it. These lines are parallel. You could even count like the spaces. So I notice here I've got like between this point and this point, I've got exactly 3 spaces. Then if I go down here between this point and this point, I've got exactly 1, 2, 3 spaces. So you could do it that way too. And then on the second one, I'll show you another way you could do it as well. So yes, we're going to say these lines are parallel because they don't ever touch. Well, then let's find the slopes. So let's pick one to be line 1. I think I'm going to go with this one. I'll make this one my line 1. So let's find the slope. This is a good point. And honestly, I think this is going to be the next good point down here at the end, because I'm seeing it doesn't really cross exactly anywhere else. Okay, so rise up and run. So I rise up 1 and I run 1, 2, 3, 4, 5. I ran 5 squares. So my slope is 1 over 5. Okay. Well, here, let me do the slope of my line 2. I'm going to name this guy line 2 down here. And I'm going to have to use those same points because I'm not seeing any other better points. Let's see. Rise up and run. So I rise up 1 and I run 1, 2, 3, 4. Oh, I ran 5 again. Oh, so this time my rise and run is exactly the same. 1 over 5 for both of them. Interesting. Okay, let's do it again. Let's see if it happens again. Let's see if our slopes are the exact same again. So I both got 1 over 5, 1/5 slopes. So here's another way you could do this. Take your piece of paper or take your Post-it note, whatever you want to do. And you could mark where each line falls, there and there. And then you can just move it along and see, oh, are your lines the same distance apart all the way up and down. Yeah, absolutely it is. So you can do this. You could hold this Post-it note up to your computer screen too. So are these two lines parallel? Why, yes, they are. They are. Because they're the same distance apart. And it looks like they're parallel. It looks like they're not touching. And they're not. They're parallel. So let's find the slopes. Okay, so I'm going to do this one. I'm going to call this guy here line 1. I think. Okay. So here's a point. This looks like a good point right here. I'll use that one. So I got to rise up and I got to run. So I rise up 1, 2, 3, 4, it looks like, and I ran 1. But I'm also noticing both of these lines are negative. So it's -4 over 1, which is just -4. I could just say the slope is -4. Okay, let's find the slope of line 2. So there's my line 2. Let me find 2 good points. I could use, guys, look, this is eerie because it's happening again. I could use those exact same points again. Okay, so I could rise up 1, 2, 3, 4 again and run again over 1. And this line is also a negative slope. So again, it's -4 over 1, which equals -4. So what are we discovering about the slopes? Well, this one, at the time they were both positive, both 1 over 5. This time they were both negative, both a -4 over 1 or just -4. So what am I noticing about the slopes of parallel lines? Looks to me like they are exactly looks to me like they're exactly the same. And that would be correct. So what have we discovered here? Well, if two lines are parallel, they're going to have exactly the same slopes. If two lines are perpendicular, looks to me like their slopes are going to be opposite signs. One's going to be positive, the other one's going to be negative, and then you're going to flip, if you know one, you could determine the other one by flipping that fraction around. And when you flip a fraction upside down, here's a little vocabulary, which was on your vocabulary. So let's say we have the fraction 2/3. If I flip that fraction upside down, this is what we call a reciprocal. That's what that's called, a reciprocal. So it looks to me like these slopes are reciprocals of each other. Interesting. So this is a true conjecture. Both of these are. Parallel lines have exactly the same slopes, and perpendicular lines have what we call opposite reciprocal slopes. Opposite signs, one's positive, one's negative, and the fractions are flipped. They're reciprocals of each other. Okay, so this was a really good discovery to make. We're going to use this quite a bit going forward. It's something we're going to come back to all year long.